Well, good evening, everyone. My name is Lisa Kleckner, and I am the director of the Finger Lakes Institute at Hobart and William Smith Colleges. I'm pleased to welcome you to tonight's event, A Conversation with Dan Egan. Before we get started, I want to cover a few of the logistics for this webinar. First, we have over 800 people registered for tonight. The webinar format means that all audience members have their video off and microphones muted for the duration of the presentation. When audience members have questions for the speakers, please enter the questions into the Q&A box on your Zoom taskbar. Finally, this event is being recorded. The topic of tonight's presentation, phosphorus and the health of our lakes, is of utmost importance to us at the Finger Lakes Institute, as well as to our surrounding campus and Finger Lakes communities. At the FLI, we conduct research and education about the Finger Lakes environment and currently have regional, state, and federally funded projects addressing harmful algal blooms, invasive species, climate change, watershed management, and contaminants across several Finger Lakes and Lake Ontario. We work with many collaborative partners, including watershed associations, municipalities, and other higher ed institutions, and seek to regularly share information and best practices to better protect the health of our watersheds. It is my pleasure to introduce one of these great partners and our co-host for tonight's event, Andy Zepp, the Executive Director of the Finger Lakes Land Trust. Welcome, Andy, and please take it away.
Great. Thanks, Lisa. And thank you all for joining us this evening. For 35 years now, the Finger Lakes Land Trust has been working with landowners and local communities to conserve significant lands throughout the Finger Lakes region and the Southern Tier. And many of those projects were driven by water quality. The health of our watershed defines the health of our water bodies. And in 2017, I think our region had a bit of a wake-up call when we had region-wide cyanobacteria or toxic algae outbreaks on every lake, and significant ones. So at that time, our organization has continued since then to conserve land, but we've also recognized the need to work with partners to restore streams and wetlands, to mitigate nutrient runoff into our lakes, and to sponsor educational programs like this. This really is a tremendous concern in our region, which is, water is the lifeblood of the region. So we're delighted you could join us tonight. And I'm delighted to welcome author and journalist Dan Egan, as well as Harold Van Ness, a professor of soil and water management at Cornell University. And Harold has graciously agreed to facilitate tonight's conversation with Dan. As time permits, we will have questions toward the end that we'll get from the Q&A. So as many as we can do, I encourage you to put those in there. And then my colleague, Edie Jodes, will share those later. And lastly, before we get underway, I want to thank the anonymous donor out there who made this program possible. And we really appreciate the ability to put on programs like this. And thanks also to all our members who support this. So with that, I'd like to particularly thank and welcome Dan and Harold, and I look forward to hearing what you have to say.
Great. Thank you very much, Andy and Lisa. And thank you for the invitation. Dan, we just met last week, but I've really been looking forward to this conversation with you. I would have preferred to have been in the room with you in person. But when I look at the number of attendees, I think, maybe the webinar format is also very good because it brings in a lot of people and prevents people from having to get in the car or even fly. Perhaps they have their feet on the coffee table and, enjoying this conversation that way. So yeah, let's get started. Dan, you have any comments you want to get started with?
Well, thank you for the introduction. And yeah, I wish I was there too, looking at the screen behind you. I think it looks way more spectacular than Milwaukee, Wisconsin's Inner Harbor, which is outside my window. But we all have the same thing in common, and that's, the health of our freshwater bodies and the Great Lakes and otherwise.
Great. Yes. I mean, that for those who are looking at the picture behind me, that is the Cornell campus with Lake Cayuga in the background, and it's actually not that far off from the view that I have from my office on the 11th floor of Bradfield Hall on campus. I'm very fortunate. So of course it's dark now. So yeah, we kind of agreed that this would be a little bit of a conversation, although of course the focus is on Dan's book. And I wanted to start with maybe a little bit of an historical perspective. The main title of the book is The Devil's Element. And I would say that has a negative connotation, right? And so yet phosphorus is so critical to life on Earth. We have plants contain a lot of phosphorus. Human bodies contain a lot of phosphorus. I think we're about 1% phosphorus, I think, mostly in our bones and our teeth, but also in ATP, compounds that are critical to the functioning of our bodies in terms of energy, enzymatic reactions and all that. But you call it the devil's element. So where did that come from?
Well, I did not create that name myself. Phosphorus has long been known as the devil's element, and it's for a couple of reasons. It's because it was the 13th element discovered, and number 13, I guess, is related somehow to Lucifer, but also it has dastardly properties. It was early on used as a weapon of war, and firebombs today are using phosphorus. They're not supposed to, by international law, be dropping phosphorus on human beings, but that is the case. That happens. So, we kind of make a deal with the devil because we need this stuff. It's in, like you said, it's in all of us. It's in every living cell on Earth and maybe beyond. It is, the bottleneck of life. No phosphorus, no life. And for a long time, we lived in balance with phosphorus. And by that, I mean there was a slow trickle of phosphorus coming out of igneous rocks after the planet cooled that would leach into the environment and was eventually taken up by cells. And when those cells died, whether they were on land or in the water, they were often recycled, the phosphorus inside those cells. And so it was like a circle of life. And once we figured out the magical fertilizing properties of phosphorus, we turned that circle into a straight line and we turned that trickle into a gusher. And that's had tremendous benefits for humanity. It's why, we have 8+ billion people on Earth. That never would have happened if we hadn't figured out how to crack this circle and straighten it out. But it's also come at a great cost because once we straightened out that line or straightened out that circle, it no longer goes from animal to pasture to animal to pasture with us on the side. It goes into our waters too often. And I can see the picture behind you is a great blue lake, and too often those blue lakes are turning green, and that's a consequence of us overusing and misusing phosphorus.
Yeah, no, it's a fascinating story. So, in a way, we went from an element that we considered to be in short supply, and being insufficient, to an element that we had in oversupply and is creating all these environmental problems. So maybe we can dig into sort of the earlier years a little bit, because you described very well some of the challenges that early agriculture and early food production had with a shortage of phosphorus, and what sort of extreme measures were being taken to try to get some of that phosphorus back onto the land. And so can you maybe dig into that a little bit?
Yeah, I was misspelling phosphorus until about 2016 when I was doing research for a book I wrote about the Great Lakes, and I had a chapter on Lake Erie. And when I say misspelling it, I mean like I was very unfamiliar with it, and so are most people. And that's a goal of this book and a goal of these kind of talks, to introduce people to the subject. But yeah, I first got interested in this when I was looking at Lake Erie and looking at the overdosing of the lake with nutrients and how that happened, and looking at the history of phosphorus. And it just turned out to be way more interesting than the book on the Great Lakes that I was writing, in my mind. I mean, the idea that humans, they intuited early on, thousands, 10,000 years ago, that, you needed to replenish the soil. They didn't know what it was, but they knew that, certain things worked well, and manure, human and otherwise, was a good source. Things started to get tighter, as humanity progressed and population grew. And England was in a real squeeze back in the 1600s, 1700s, and they were looking for anything that they could get their hands on to make crops grow. And this is where I really got interested in this when I was reading how, for some reason, they determined that bones were I think well I actually they determined bones were a great fertilizing property because they had a lot of bone shavings from knife factories. The knife handles were made from animal bones, and the shavings were put on crops and made things grow. And so then they didn't know it was phosphorus, but they knew they needed bones. And so they plundered Europe for bones. The Battle of Waterloo took place, I think, in 1815. And by 1824, 25, there were no bones, and there was no mass burial, and there was no, you know, cemeteries with all the remains. The British went back and plundered the battlefields for the bones, and they built specific mills to grind those bones, to spread them on the land, to make turnips and wheat grow to feeding, borderline starving population. And so that worked for a while, but there's only so many bones out there, and they had to find new sources. And that's really the story of phosphorus. We're always on the hunt for it. This modern chapter is a little different. We know where it is. We're just using it too much now. But.
Yeah, I found the your description of the bones and where they came from very fascinating. It's horrific to think that on these battlegrounds where many thousands and thousands of soldiers died, that they were scavenging for their bones and taking them, across the channel to England. I hope no one ever makes a movie about that. That's just a horrific thought. And you also mentioned, the mining of guano, especially from some of the islands off the South American coast.
Yeah.
And that creating all kinds of problems. But it was an indication of how desperate the situation was, right?
Yeah, and I would make the argument that it is gruesome and grim on one level that we were grinding up bones of fallen soldiers of our sons, and turning them into bread. But life on Earth is rough business, and you need to put food on the table, and you need phosphorus to do that. And at that time, the source was bones. And after those bone deposits, those battlefields played out, the hunt went on. And yeah, exactly. The English and most of Western Europe and North America ended up on the western coast of South America, off of Peru, mining these islands that were just basically desiccated bird poop that had, accreted over millennia, and that bird poop was lousy with phosphorus. And again, this is like in the 1830s, 1840s. And at this point, chemistry got involved, and the chemists realized what it was about bones and other materials that made it such a great fertilizer, and it was the phosphorus. So they could focus a little bit more on actual substances, and they focused on this bird poop, which also happened to have nitrogen and potassium, the two other main components of modern fertilizer. So it was almost like a store-bought fertilizer just stacked up on these islands. And at the time, it was thought that there was so much bird poop on these islands that it was inexhaustible. If not inexhaustible, it would last beyond anybody's comprehension. That was like in 1840 or 1850. In 1880 and 1890, it was gone. We had mined those islands, and so now we knew we needed phosphorus. And the next caches we found, and the caches that we rely on today, are basically sedimentary rock deposits, which are really the sum total of dead plant life accreting on the ocean floor and making its way through tectonic or other forces onto land where it can be mined. But there are not many of these deposits. They're relatively scarce, and they're being rapidly consumed. And so even 30 years ago, we were thinking that we had basically nothing to worry about as far as finding phosphorus to grow our food, to the point now where I don't think we're going to run out of it as a planet in the next 200 or 300 years, but there's going to be regional scarcity. And here in the US, that's going to mean we're going to become dependent on other countries because our deposits are mostly in Florida and they're being rapidly consumed and they're predicted to play out in 30 or 40 years, at which point we become dependent on another country for our nutritional security, which is arguably a lot more important and complicated than energy security because there's workarounds for oil, but there's no workarounds for the phosphorus that is in every living cell. Morocco happens to have, Morocco in its occupied territory of Western Sahara has 70 to 80% of the world's reserves. And, at some point, the world is going to come knocking. And how that plays out is.
It's really very interesting how much more than, say, oil or most other mined products, phosphorus really is very heavily associated with one country. And I want to come back to that, but before we do, I was kind of struck that the 1800s were kind of a critical time when perhaps due to population growth, the Industrial Revolution, Malthusian thinking, Liebig, you talk about Liebig, which a German scientist who identified the critical nutrients and really kind of put phosphorus on the map. John Laws, the Englishman who came up with a way to treat these phosphorus deposits to make a concentrated form, superphosphate. And also, and you don't discuss that, but I'd like to point that out, is that in the mid-1800s, there was more recognition of what was called the metabolic rift. And it was actually Karl Marx, yes, that Karl Marx, who kind of started to point out that, if we have increasing concentration of human population and urbanization, that means that we have these nutrients like phosphorus going from the farms to the urban areas, and they're not being returned, right? The only exception to that a little bit is the city where you are, Milwaukee, right? Milwaukee actually has a program where they recycle some of that human waste as fertilizer material.
We were pioneers. I think that was German technology, and the city of Milwaukee was very farsighted at the time in the 1920s or early 1930s, and they went over and I think they got sued internationally actually for the process that they developed. But the byproduct of it is now known as Milorganite, and it's not a food fertilizer, but it's used in lawn care and other applications. And we recognized here in Milwaukee that there was a value in our waste, and in antiquity they recognized that, but too many people today don't really view our waste as not just human waste, but animal waste, mostly animal waste, as the nutritional trove that it is. I mean, again, it goes back to this circle of the land needs to be replenished, and that only it's just common sense. But we've taken it to an extreme, and we've been able to do it because everything's been relatively cheap since we locked onto these rock deposits in the early 1900s. But there's a bill to pay, and there's a paradox going on here too. We're running out of this stuff, inevitably, inexorably. At the same time, we're overusing it to the detriment of our water bodies. So that's, and what I talk about in this book are really, it's got to put food on the table, but you also have to protect water, and safe water and safe food shouldn't be mutually exclusive enterprises. But at the moment and on the path that we're on, that's where we're headed. You look at what happened in Toledo in 2014, more than 500,000 people lost their drinking water because the western basin of Lake Erie was polluted with phosphorus, which led to toxic algae outbreaks, which led to a shutdown or a do not drink order in the metropolitan area of Toledo. And this wasn't a case of like, boil the water and you'll be fine and we're going to get this online. Nobody knew how long it was going to be out, and you couldn't boil your way to safety because that would only concentrate the toxin of this bad algae that's being grown by this phosphorus being unleashed on the lake mostly from farms. And so the National Guard was called in. I was there that week. The National Guard was called in to bring truckloads of water, drinking water, baby formula, pallets of baby formula, because they were living on the edge of the world's largest freshwater system, and they couldn't trust a drop of it, which was harrowing.
Yes, that's remarkable. Yeah. Um, but you also discuss, you have a chapter that's titled Dirty Soap, and in a way sort of a prelude to the discussion around the agricultural phosphorus, and that was that there was sort of industrial phosphorus, which I think was initially a bit of a mystery of, how that impacted the lake. And it was, a very interesting discussion of a gentleman, I think Dr. Schindler, I think was his name, doing some experiments in Canada. But you're also kind of contrasting, the challenges that come from industrial products, but that are in a way more manageable, especially under the legislation that we have, the Clean Water Act, as opposed to the agricultural non-point source phosphorus that is a lot more difficult to deal with, right? So maybe elaborate a little bit on that.
Yeah, well, I mean, what Harold Schindler, he just passed away, I think 3 years ago this week, maybe today. But yeah, he was an ecologist who was basically tasked with figuring out why North America's water bodies were turning so putrid green back in the 1960s. Dr. Seuss wrote the Lorax in 1971 or 1972, and in it he makes a specific reference to Lake Erie, and I don't remember the exact line, but he talked about the fish were leaving Lake Erie where the water wasn't so schmeary, and he had pictures of fish waddling on their fins out of the water. And it was really, ingrained in the national consciousness that our water was going bad and nobody knew why. And the Canadians got bold and said, well, let's figure it out with big lakes in the wild rather than aquariums and test tubes in the lab. The thought being that you can't really replicate nature, in the truest sense in a laboratory. So they were given basically, carte blanche to take these lakes in far northwestern Ontario and treat them as test tubes and aquariums, and basically poison them with this and that to figure out what was causing such trouble on Lake Erie and lakes across the continent. And at the time, it was thought it could be carbon, it could be nitrogen, it could be phosphorus. And phosphorus was really a third rail at that point because the detergent industry relied heavily on phosphorus in their formulas. We didn't have detergent until like the 50s and the 60s to any significant degree. And we got detergent, which is synthetic soap, following World War II. And when we stopped building tanks and planes and other weapons of war, we turned our focus on, conveniences at home, like refrigerators and washing machines. And it turned out that washing machines didn't do a very good job with regular traditional soap. So we had to formulate this chemical concoction that turned out to be largely based on phosphorus because it did a remarkable job of pulling minerals out of hard water and making our clothes white and soft, our whites whiter and our brights brighter. And, people in their basements doing laundry were really happy, but people on the beaches were not, because that detergent made its way through wastewater treatment systems, such as they were at the time, and was making its way into the lakes. And it turned out only through Schindler's work that it was proven that it was phosphorus. And he proved it in a very elegant and simple way. And that was, it was basically nitrogen or phosphorus, which is the problem. And I know nitrogen is a factor today, and it's becoming recognized as a bigger, more and more of a factor. But at the time, they were just wondering, what is the one thing we can pull from the waste stream that's going to give us fast and dramatic results on water? So what they did for their experiment, in simple terms, they just put there was a peanut-shaped lake with a pinch point, and across that pinch point, they put a polyurethane curtain from the top of the lake to the bottom, and one side got phosphorus and one side got nitrogen. One side got nitrogen and phosphorus, I believe, and one side just got nitrogen. Side that got phosphorus turned golf course green. in like 2 weeks. And they went up in a helicopter and they took a picture of it. And that was way more effective in convincing the public that something was amiss than any kind of, you know, chart and graph. And so this was in 1970 or 71. And by 72, we got the Clean Water Act. And the Clean Water Act basically said, hey, industry, you got to stop dumping whatever you want in the lakes. And you got to start pulling phosphorus out of your detergent concoctions. And they did that. And by 1986, Lake Erie had recovered so dramatically that Dr. Seuss pulled that line from the Lorax. But he'd put it back today if he were alive, because the lake's green again. And now it's not green because of laundry detergent. It's green because we got the Clean Water Act in 1972, which did wonderful things for water bodies across the continent and set an example for the world. But it failed to regulate, to adequately, I would argue, regulate agriculture. And the thought at the time was that pollution coming off fields was too diffuse and not significant enough to warrant any kind of dramatic regulatory measures. And they were right for the first 10 years. We did get the water quality improvement, but things have changed since 1972. We're more than a half century down the road, and we don't farm like we used to. The size of some of these farms, you know, I'll just jump back here, and I hate to use these words, but point source and non-point source. Those are the terms in the Clean Water Act. And the Clean Water Act went after point sources, which is basically anything coming out of a smokestack or a pipe, because you can plug those or cap those or scrub what's coming out of them. But you can't really squeegee a cornfield, right? And so they left that alone and thought, that's a high-hanging fruit. Let's go after the low-hanging fruit. So we went after the low-hanging fruit, and that's gone. But that high-hanging fruit is now pretty low because these farms are no longer, you know, 50 years ago, 75 years ago, a big farm was 50 cows. We now have farms in my home state of Wisconsin that are approaching 10,000 head of cattle. And those cows aren't on pastures grazing and pooping and growing more grass with their poop. They're confined to barns, and they're fed grains that are very often coming not just from another farm, but from another region, if not another state or another country. And so we've got this massive accumulation of manure on farms all across North America. And when you see these lagoons, you would be hard pressed to not say that is a point of pollution, a source of pollution, a point source. And common sense acknowledges that, but the federal government doesn't. So the Clean Water Act is largely left, and I don't want to demonize agriculture. They're just working in the system that, you know, they've inherited. They did help shape it, but that's to be expected. And it worked for a while, but now that non-point has become a point source pollution. And we need to not only recognize it as something that needs to be regulated, but we also have to get beyond looking at it as pollution. That is a nutritional trove. We were talking earlier about the lengths that the British were going to, you know, plundering battlefields and scouring islands off of Peru, scratching any little, you know, atom of phosphorus they could get, molecule. There now, you know, we've got gobs of it and no way to handle it, and no, you know, history of refining it and returning it to the land. So it typically just gets spread across the landscape, whether the landscape needs it or not. And that's why that lake behind you that's blue is in danger of turning green too often.
Right. And that's it's interesting, you know, this history. And I remember coming to Cornell, starting my job some decades ago, and some of the colleagues who were still around who were part of the debate about the detergents and all that, and how they showed that, you know, especially Cayuga Lake and the other Finger Lakes were really improved by the detergent ban, and that we're now sort of in this situation again, and in a way in a paradoxical situation, because we're talking about, you know, phosphorus supplies, you know, being limited, or we talk about peak phosphorus, yet we have all these excess phosphorus problems, right? And so it really is in a way a problem with the structure of agriculture. And you explained that so well. You know, livestock farms are a big part of the problem, One of the things that I recently started to pay more attention to is these flows of nutrients, including phosphorus and nitrogen, that happen within regions. You mentioned, maybe dairy farms in Wisconsin who get their grains from Iowa or Minnesota, and so a lot of the nutrients, the phosphorus, come with that, and they accumulate on those farms. But we also have these very large global transfers of nutrients through the global grain shipping industry. So as you may remember, a few years ago, we were in a trade war with China, and one of the things that we decided to fight them on was imports, and the Chinese retaliated and said, well, we're not going to be buying any more of your soybeans. And that sort of pointed out that we are shipping a lot of soybeans to China, a lot of corn to other Asian countries. And so what that means is that that's the same situation as we have at the continental scale here, is that we're transporting all those nutrients from one place to another. So we're losing them from our soils, where we are producing all these grains, the corn and soybean, and they're accumulating not only in Wisconsin, but also in Southeast China, where they have huge pig raising facilities, and they don't know what to do with the manure, and they are now having these problems just like we do, right? So part of it is a structural problem that we've gotten into a structure of agriculture where we specialize, we have grain producing areas, and we have livestock producing areas, and we ship all these nutrients from the grain producing areas to the livestock producing areas, and sometimes we do it literally by the boatful. So is there an easy solution to that, Dan? I mean, what are your thoughts on that?
Well, yeah, and as you're saying, so we ship the grain, and so as we constantly fight to replenish our soils, we're saturating the soils of Asia with too much manure. And it goes back to this circle of life concept, which seems too simple to really take seriously, but it isn't. Let's talk about a cow on a traditional farm, and the rule of thumb used to be, as I understood it, one cow, 1 acre. That acre would supply enough grass to sustain that cow. That cow would eat that grass. That cow would poop. The phosphorus and the other nutrients in its poop would fertilize more grass, and on and on and on it went, as it did in the forests and the prairies and everywhere across Earth. And so now, the scale has gotten so much greater, but the circle still needs to be reconnected. We're not going to get back to the era of 1 cow, 1 acre farms, but we need to get back to the mindset that what's coming out of the backside of those cows is probably as valuable as what's coming out of their udders. There's been studies here in Wisconsin where we've got a lot of manure. This is dairy land, and we're awash in it. And we're trying to figure out what to do with it. And this is a good step in the right direction. I mean, there's now methane digesters that are in use across the state, and they're able to strip the methane out of the manure and put it into the grid. And it's running all across the country, and it's considered a resource. And to the point that in some years, some farmers say they're making as much money on their methane sales as they are on their milk sales. That's just the first step, though. I mean, once we've got our hands on all this manure, that's really kind of the first principle in waste management, right? You concentrate it, you get it in a place where you can do something with it. And the first thing we're doing is we're stripping the methane from it, but we can also get the nitrogen and the phosphorus out of it. And the rule of thumb right now is if a farmer has to move his manure or her manure more than 10 miles, it's a money-losing proposition. And these guys are too often operating on very slim margins. But if you were to process this stuff, if you were to treat it the way we treat human waste, not identically, but with a similar mindset that we need to keep the bad stuff out of the water, that would mean, particularly with cow manure and pig manure, that'd mean a lot of good stuff on the land. We could concentrate, pelletize, commodify, ship this refined cow poop that's going to be pure as anything coming out of a mine in Florida or Morocco and grow food. It's just a mindset that we've got to reestablish, that there is a circle of life that we have to respect harnessed and sustain if we want to sustain ourselves. It all starts, everything starts on the landscape. And that's why we have all the products that we have. That's why we have SUVs and flat screen televisions and second homes. It's all based on how productive and how sustainable what we're doing on the land is. And we don't have enough of a public consciousness. We don't have enough public people in the general population recognizing this and demanding that we create a new, more refined system. I'm not advocating, although it would make a lot of sense to solve this problem, for dramatic change in our diet, but those are higher hanging fruits. Right now, the low hanging fruit are those lagoons of manure that are just being blasted on the landscape and then washing off that landscape and turning those waters green.
Yeah, no, I absolutely agree, and I think a couple of maybe more optimistic perspectives would be that that there are approaches that we can be creative. There's you kind of alluded to the more circular economy, or the bioresource management, whether the bioresource is from livestock farms, or maybe even from more urbanized areas. And for our New York audience, I know there's a lot of people here from New York. I recognize many names, by the way, on the attendee list. We're actually in New York. We're actually in a very favorable position in that we have a lot of diversity of farming systems. For example, we have dairy farms that dominate certain counties in the state, like Wyoming County and Cuyahoga County, but they're not that far away from farms that are focused on, say, processing vegetable production or cash grain production. And so the latter farms tend to be deficient in phosphorus. So if they're not that far away, and you maybe dry the manure or you process it some other way, then if we spread it around and we kind of cycle it back to some of these farms that are low on phosphorus, and we kind of relieve that excess phosphorus from the livestock-based farms, that's a tremendous opportunity. And we really need to start thinking about not only what's the source of what sources are available, for example, manure or maybe municipal compost or something like that. How do we process that, right? So methane digesters, as Dan was saying. There's other ways, maybe drying, torrefaction. People even talking about pyrolysis and biochar. Maybe these are options that we can also pursue. And then we have to think about the logistics of, can we get some of that material then to the places where it is beneficial? And one of the good things about the phosphorus in an organic form, like manure or compost, is that it's also good for the soil, that it helps the health of the soil, because it comes also with carbon and nitrogen and other nutrients that feed the organisms in the soil and that help improve the health of the soil. So there are win-win opportunities, but from my perspective, there's a couple of challenges. One, the economic forces tend to push us towards this specialization and doing things very economically, right? And sometimes what we're proposing to do that's more sustainable is not quite the optimum economic solution. So we need to think about, how do we address that? Maybe some subsidies, cost sharing, things like that. And we just need to change our mindsets a little bit, right?
Absolutely. I mean, I think a well-implemented regulatory structure doesn't put anybody out of business. Nobody wants to put farmers out of business. This is the most noble profession there is, as far as I'm concerned. But there are costs that we're paying right now that we don't even recognize. Let's look at a gallon of milk. Okay, it's pretty cheap these days compared to what the family paycheck is, but it doesn't take into account on that ledger what's happening in the lakes. Those are real costs. And I'll point out the University of Wisconsin. They've got the Center for Limnology, which is the Center for Freshwater Studies, right on the shores of Lake Mendota. And they also have some of the best soil scientists and agronomists in the country, Cornell notwithstanding.
Yeah. A lot of them are Cornell graduates. So,
yeah. but the thing is that Lake Mendota, is right on campus, right on the edge of the campus, and it is spectacular, but you can't swim in it very often in August because it's got toxic algae, and that's because of the dairy that's in the same watershed. So what you've got to figure out how to keep that. I'm just thinking off the top of my head, but it's a pollutant when it hits the water. It's a nutrient when it's on the land. We need to figure out how to do that. Keep it out of the water and keep it on the land where it's needed. And when I talk about this algae, I'm not talking about some kind of unsightly, unpleasant, mildly disgusting thing at the beach. It has real health impacts on humans and animals. It commonly kills dogs. Anybody listening can just Google toxic algae dogs, and you'll be horrified to take your dog to the beach come July or August. And I don't want to be sensationalist, but or sensational, but you probably should be. And this, for humans, it's a liver toxin. This is a little controversial, but there's been studies that it's been linked to neurodegenerative diseases like ALS. And I talk about this in my book, The Devil's Element. And I talk about it very cautiously because I'm not, I'm a journalist. I'm not, trying to scare people for no good reason. But there's some studies that have come out, particularly one from Dartmouth, where they were finding clusters of ALS among people who lived near lakes that were infested with this toxic algae. And you don't have to swim in it. You don't have to drink it. It can aerosolize. It can be in the air, and it can be picked up. I'm not going to put a number on it, but it's hundreds of yards, if not more, away from that lake. So we're not just looking at protecting the sightliness of a beach or stopping the unsightliness of this stuff. We're looking at protecting ourselves. It's a lot of common sense here. And when I talk to people, they say, why haven't we heard about this, or why aren't we doing anything about it? And it's because it's kind of complicated. There are dots that you have to connect that don't fit, on the Chiron or whatever it's called on screening across the bottom of your nightly news. It takes some thought and some thoughtfulness to really figure out, or to get connected in your head, that we have a problem that is significant. It's not easily fixable, but it's inevitable that we have to do something about it, or we're going to end up with bad water and bad farmland. And
yeah, I absolutely agree on that part. And one of the interesting things that I've sort of become more aware of in the past couple of years is that so there is some legislation that exists related to the Clean Water Act for farms, and that's the CAFO legislation, right? These large farms, confined animal feeding operations, and they have requirements to develop comprehensive nutrient management plans. And these are quite impressive. I mean, I've seen a number of them, and they can be 250 pages or something like that. Looks at the soil analysis and the maps, and how much, what crops are being grown, how much manure is being generated, where it needs to go. But I'm starting to quietly whisper and say, these plans are great, but there's no follow-up. I've seen cases where there were considerable problems with cyanobacteria, but the farmer was following the comprehensive nutrient management plan. And so there was not any, from the farmer's perspective, they were doing things right, but yet we still have a problem. And so I think this is the next generation of looking at this problem and saying, yes, we've put some requirements in for the farmers, but we haven't been very good at following up and see whether these requirements actually are good. And so,
or if they're implemented uniformly enough to make a difference. There was a Ohio State University study that came out in 2011 or so in the western basin of Lake Erie, where they surveyed farmers and they said, is there a problem with manure getting into the water and creating these toxic algae blooms? And I don't remember the numbers, but like almost all of them said yes. And then 70% of them said, but I'm doing the right thing.
yes.
So, and again, like it's really, it doesn't do any good for the problem or for relationships to demonize farmers. They want to fish on the weekends. such as a weekend is when you're a farmer. But they you know, in Western Lake Erie, these guys are outdoorsmen. They want to be able to enjoy their lake. They're not the bad guys or the bad people, but the system is bad. The system is, and the system isn't malicious. The system is just archaic. It's just doesn't. It's not built to handle, 2022. It was built to handle 1972, and we're suffering the consequences of it. And I hope we collectively, as a society, can step up. My shirts aren't as white as my grandpa's shirts probably were, but they're white enough. You can't have everything. And so I bring up the whiteness of the shirts because at the time the detergent industry was saying that we were headed for ruin and pestilence if we, abandon this modern miracle of phosphate-based detergents. Well, we did. We're doing fine. And the glasses coming out of the dishwasher might be a little smudged, but we're all learning to live with it. And for a long time that meant that we had safe, clean beaches to swim at. And we can get there again. We just need to have the will, the collective will that 2 generations ago we had.
Yes, great. That's fine. And I'm looking at the clock, and it's 8:20, 7:20 for you, Dan. So I would like to sort of turn it back to Andy and Lisa, and sort of open it up for some questions and answers.
All right, thank you, Dan and Harold. My name is Edie Jodes. I'm the Assistant Director of Communications for the Finger Lakes Land Trust. Here with some of the most popular questions. First one is, Dan, can you tell us what the interaction of phosphorus and non-native mussels does to enhance toxic algae?
Yeah, that's a very good and interesting question. So back in the 1960s, when Lake Erie was so green, Time magazine was calling it America's Dead Sea. It was green and considered dying because there was so much algae growth that when that algae died and decayed, it basically sucked all the oxygen out of the water. So nothing could really survive in the water column. But the algae itself at that time wasn't necessarily toxic. It was an assemblage of a bunch of different species. But in 1986, we discovered the first zebra mussel in North America, in Lake Erie, I believe. And zebra mussels come from the Caspian Sea basin. And these brainless little mollusks, not any bigger than your thumbnail, are smart enough to not eat toxic algae. So they will suck everything out of the water column. Healthy algae is like the base of the food chain. They will consume that, but they will spit out the toxic algae. So what they're doing is selecting for the nasty stuff. And so when you get an algal bloom or an algae bloom, today, more often than not, it's going to be toxic, and it's commonly microcystis, which is, well, I don't want to get too far into the weeds, if you will. But yeah, the mussels are basically filtering the good stuff out of the water and leaving the bad stuff. So when that fertilizer hits the water, the bad stuff has no competition, and we get toxic algae blooms that can span thousands of square miles.
All right, next question. To what extent do the design and function of our roadside ditches contribute to phosphorus and nitrogen loading in freshwater bodies?
Harold might be better equipped to answer this, but I'll just say real quickly, when fields don't drain well, naturally they need help. And that often means drain tiles, which are basically pipes underneath the field that lead to these ditches. So they kind of mainline what's on the soil and in the soil into the lakes. And, often that's phosphorus and nitrogen, but Harold may be able to speak better about that.
Yeah, I can address it a little bit. So there's sort of two issues. So one is the roadside ditches, and the other one is those below the ground drainage lines, these tile lines. The latter tends to be really a big concern, especially with soils that are a little heavier, like maybe higher in clay content, because that manure and the phosphorus can sort of finds its way through the cracks in the soil very readily. And so rather than being filtered by the soil, it goes into the drain lines, and then it ends up in the roadside ditches. So that's a real concern. The roadside ditches themselves maybe don't have a big source of phosphorus. It's just that what comes into those ditches from the agricultural tile lines or drain lines is a big problem when a lot of phosphorus, and especially manure, is applied. And I should do a shout out to my colleague Rebecca Snyder, who got me actually this gig here, who is a colleague here at Cornell University, who's done a lot of research on roadside ditches. So if you're interested, send an email to Rebecca or my colleague Todd Walter here at Cornell as well. They've done a lot of research on roadside ditches.
All right, next question. Dan, can you tell us, to what extent do household lawns contribute to toxic algae outbreaks?
Well, I don't think there's been an outright ban on phosphorus in lawn care products across the country, but the manufacturers have pulled it. There are exceptions. You can get phosphorus if you're trying to grow a new lawn or have some other justification for it. But those are localized impacts. A small lake in the forest with a bunch of lawns around it is going to be affected. But on a larger scale, the scale that we're talking about, lawns and even golf courses really pale compared to agriculture. Agriculture and also human waste. And so in this book, I start in Hamburg, Germany, where phosphorus was first discovered as the 13th element, the devil's element. And this alchemist was looking for the mythical philosopher's stone that would turn base metals like lead into gold. And he thought he could isolate it from the waste stream, and he ended up, isolating phosphorus along the way. It turned out the human waste stream couldn't turn anything gold, maybe a snowbank, but nothing beyond that. That's a joke. But anyway, so phosphorus was basically born in Hamburg, Germany. Hamburg, Germany was burned to the ground in 1943 by incendiary bombs, many of them loaded with phosphorus pellets. And today, Hamburg, Germany is leading the way toward a more sustainable future because Germany has on the books a law that's going to require basically all phosphorus from the human waste stream coming from major wastewater treatment plants to be essentially phosphorus free. And they've built a plant that's on the banks of the Elbe River, and it's doing its job, as I understand. So human waste, animal waste, those are the big fruits. Whether they're hanging low or hanging high, those are the fruits that we've got to go after. The other stuff matters, and it matters, in a way of in the sense that we want the public to be thinking about these things and doing their part. But the big inputs are coming off the land and out of cities.
All right. Between the two books, you interviewed a lot of people on different sides of the issues. Do you have favorite anecdotes about people's reactions to your inquiries?
Well, I'm a journalist. I spent 20 years at the Milwaukee Journal-Sentinel, and I write these books with a journalist's training and a journalist's kind of sensibility. And I'll say over and over again, I'm really not trying to attack anybody, demonize anybody, hurt any livelihoods. I'm just seeing dots, connecting them, and making the picture that I think the public needs to see. And so it's my favorite part of the job, actually. It's the only time of the job when I'm not stressed or looking at the clock, is when I'm talking to people in the field, doing their work, seeing where they're coming from. And I don't have any particular favorites that I would want to bring up now, but I've met a lot of great people. And the one thing that I've learned is everybody cares about the water. They do. It's just they don't know. We don't know. We're not doing enough to help people do the right thing to protect the water and the land and our crops.
Next question. What are your, oops, sorry, hold on 1 second. I have to scroll back up. What are your perspectives on granting water bodies rights to address pollution? Many countries are implementing rights of nature for lakes and rivers.
That's a legal question that I'm not well versed in. I can't really give you a great answer, but I think intuitively, when we're protecting the water, we're protecting ourselves. It's just that's common sense. And if measures like that help us get there, great. But I don't think we need to do anything more than really just implement our common sense and our collective desire to live in a place where we can trust the water and trust the food.
Yeah, I maybe would add that, we have pretty strong, by international standards, fairly strong legislation on water quality protection through the Clean Water Act. The permitting process, and with farms, of course, are the CAFO legislation. New York State has some additional legislation. I'm not an expert on that either. But I do think we have a fairly strong legal framework, and we have water quality standards, metrics for water quality. That one of the challenges is that it's not always that easy, especially when it comes to non-point source pollution and agricultural pollution. It's not that easy to solve those problems, because it's difficult to regulate the industry, because it's a very nuanced issue. It's very site specific, even time specific. So yeah, some of these things are not easily addressed. I think we have a legal framework. It remains very difficult to implement those regulations, because it's not easy to do.
Well, I would just say real quickly, I don't entirely agree. I think that the Clean Water Act did a great job with the point sources, but the non-point sources were largely exempt, and they are largely exempt today. So, CAFOs are heavily managed when you're talking about the working areas on the farm, the barns. But once that manure leaves the barns, it bureaucratically becomes a non-point source pollution, and too often it's spread on lands that don't need it, and it makes its way into the water. And that's the one thing that I would really hope that my work in this book accomplishes, is to get people to look at, like, what were our motives in creating the Clean Water Act 50 years ago? Is the Clean Water Act working as we hoped it would? And if not, and I would argue it's not, what do we need to do to make it so? And it is complicated, but it's not that complicated when you see the size of those manure lagoons. It's right there. It's like, let's do something with it. It's not a bunch of yuck. It's just a bunch of yum. It's food. It's our future.
And to some extent, I think it's a cultural issue in that, if you look, for example, at Europe, they're much more willing to regulate agriculture, but they also provide a lot more subsidies to agriculture, so you can be a little bit more demanding. In the U.S., we rely more on voluntary adoption. That we're trying to support farmers, but ultimately farmers retaining a lot of the decision power to decide what they want to do on their land. And that's not always in the societal interest, as Dan was saying.
Yeah, because what happens on their land ends up in our water, everybody's water.
All right. Dan, last question. What gives you hope that we can solve this problem?
Common sense, we all have it. We're just, it's just a matter of informing the public and getting them thinking about these things. This issue is getting more intense. I mean, maybe it's more media attention, or maybe it's the algae problem is getting worse. I think it's both. But, start looking at the papers come June and July, and there's algae outbreaks everywhere, and people don't know where it's coming from or why it's happening. And there are reasons. I mean, we understand what's happening. We actually had a plan for Lake Erie back in 1970, 71, after these experiments up in northwestern Ontario, that put Lake Erie on a phosphorus diet, and it worked. We have a plan now, we being the United States and Canada, to do the same thing. We have a phosphorus diet prescribed for Lake Erie. and everybody's signed on to it, but it has no legal enforcement. And so again and again, I want to say that not interested in making life difficult for farmers. I'm interested in seeing a rational system of pollution regulation that will keep farms humming and keep our beaches safe to swim and our water safe to drink.
Well, Dan and Harold, we're at our appointed hour, so I want to thank you both so much for sharing your experiences and expertise. And Lisa and everyone at the Finger Lakes Institute, I want to thank you for your partnership in making this possible. And again, we're sorry we couldn't get to everyone's question, but we got to as many as we could, and we hope to continue this conversation. So clearly we've got a ways to go, but thanks everyone for making this happen.